Welcome friends, welcome to the channel UPSC Maths. So in last video, we have discussed how to solve linear programming problem using graphical method. We will solve some more sums in this video. Let's start with the sum. So we have to minimize z is equal to 3x plus 2.5y subject to constraints 2x plus 4y greater than equal to 40 and 3x plus 2y greater than equal to 50. And this x greater than 0 and y greater than 0 indicates that the solution space lies in first quadrant. Step 1 is to formulate mathematical model. We will skip this step since the given question is already in mathematical model. Step 2 is to consider the constraints as equality and plot them in coordinate plane. We have two constraints, 2x plus 4y greater than equal to 40 and 3x plus 2y greater than equal to 50. When we consider the constraints as equality, we get two equations. 2x plus 4y equal to 40 and 3x plus 2y equal to 50. To find the coordinate points, let's draw the table. When we put x is equal to 0, we get y as 10. So our coordinates become 0, 10. Let's put y is equal to 0. So we get x as 20. So the coordinate points become 20, 0. Now let's draw the table for second equation. When we put x is equal to 0, we get y as 25. So the coordinates become 0, 25. When we put y is equal to 0, we get the value of x as 16.6. So the coordinates become 16.6, 0. Now let's plot the points in coordinate plane. So this is my coordinate plane. I have taken scale as 1 unit is equal to 3 unit on both the axes. Let's plot 2x plus 4y equal to 40 whose coordinates are a 0, 10 and b 20, 0. Let's plot 3x plus 2y equal to 50 whose coordinates are c 0, 25 and d 16.6, 0. Since both the lines are intersecting at some point, let's name it as E. To find the coordinate points of E, we have to solve these two equations. Use the scientific calculator to get the values directly. You will get x is equal to 15 and y is equal to 2.5. Now we have to determine the convex region. I hope you remember this statement. If the condition is true, the region will be below the line, and if the condition is false, the region will be above the line. And the cheat code TB. Let's find the region for 2x plus 4y greater than equal to 40. Put x is equal to 0 and y is equal to 0. We get 0 greater than 40, which is false, and hence the region will be above the line. Let's find the region for 3x plus 2y greater than equal to 50. To find the region, put x is equal to 0 and y is equal to 0. So we get 0 greater than 50, which is false, and hence the region will be above the line. So the intersecting region becomes the solution space. Hence, the convex region is CEB. Step 5 is to calculate the value of objective function at each vertex. We have C 0, 25, E 15, 2.5, B 20, 0, and the given objective function is minimize z is equal to 3x plus 2.5y. When we substitute the values, we get objective function at C as 62.5, objective function at E as 51.25, objective function at B as 60. Since this is a minimization type of sum, we have to consider the least value, which is 51.25 and obtained at E 15, 2.5. And the optimal solution is x is equal to 15 and y is equal to 2.5 and z min is 51.25. We have another method to calculate the objective function. For that, consider the given objective function as 0. So 3x plus 2.5y equal to 0. When we solve this, we get the coordinate points as minus 2.5, 3. When we plot this point in coordinate plane, we get line like this. Now, draw the line parallel to itself as near as possible until the closest point within the feasible region is touched by this line. So this is the parallel line which is as near as possible and the closest point within the feasible region is touched by this line. And the point here is E 15, 2.5 and hence Z min becomes 51.25. Hence, the optimal solution is x is equal to 15 and y is equal to 2.5 and z min is 51.25. So that's it. You can practice these sums. Thank you for watching. Don't forget to subscribe the channel.